is like number 25 from the last homework assignment. And a lot of you I went over this with yesterday in class, but some of you didn't get around to it yet, and then you did it last night. And what I saw a lot of for a solution is just z equals, actually it was 25 and 7. Yeah, z equals the square root of 27 times 16. That's what I saw a lot of. And that's not the case, okay? So a little confusion about how we set up this square root thing. Because if I set up my triangles here, right, I set up my papa triangle, my mama triangle, and my baby triangle. The baby's kind of a teenager now, in case you haven't noticed. The big outer triangle, I don't know the long leg. I do know the short leg is 27, and the hypotenuse is z. The middle triangle, I really don't know anything for. The little triangle, I know the short leg is 16, and the hypotenuse is 27. So when I set this up that way, I get z over 27 equals 27 over 16, or 27 squared, which is 729, is 16z, and then we divide by 16. So z equals, and then we're just, that doesn't reduce, so we'll just leave it like that. 729 over 16 is fine. Okay? So we set up our triangles, it works that way. But when people were doing it with the geometric mean situation, what they were trying to do is always just whatever, set the variable always by itself. Was kind of the thought process I think you were having when you did that. And the problem is that's not the way it always works. The way it works is the two that go together on the same line are the two that go together under the radical. And that's the setup. The one that's by itself, which is one of the three, I think I call them the spokes of that right angle in there. The one that's by itself is by itself in the equation too. So it's very consistent. Now to solve that, little algebra stuff here, we square both sides of the equation. 27 squared is 729 equals the squared cancels the square root 16z, and we divide by 16, getting the same answer as we got down here. Okay, so it works the same way. But it's not just the variable equals the square root of whatever the two numbers are, which is what I saw a lot of people doing. That's not the way that works. Now, it's not a huge part of your quiz tomorrow, this stuff, but it will, obviously, there'll be a question on there. And you can choose to use either the geometric mean method or the drawing the triangle method. The geometric mean method, if you can do it correctly, is much faster. But the drawing the triangle method sometimes is a little safer. Just a reminder, by the way, folks, your phone should be away right now. Your computer should be away right now. Your earbuds should be out, and you should probably have your review sheet on your desk. If you haven't picked up a review sheet yet, go get one off the back table. Okay? Because they're all things you're going to need right now. And we do not need our other electronic devices out. Okay? All right, let's go over the review. And again, I've literally just copied the problems directly off your review packet onto the smartboard here so we can go over them problem by problem. Now, just glancing around here, once again, I am noticing that most of these review sheets, and I'm looking at them, are blank right now. I got a few that have some problems done, which is fantastic, but most of them are sitting here blank. And again, you are not reaping the benefit of this review if you are just waiting until now to see how these problems are done. The benefit from this review will come from you actually trying all the problems at first, being successful on some and unsuccessful on others, and learning where you need to brush up your skills. So about 2/3 of you right now or more probably are not getting the full benefit of this review. And it's by your own choice that you're doing that. The other thing you need to be doing as then we're working through this is taking notes. If you just watch me do the review, It's a spectator sport for you then. And you do not become better at a sport by watching other people do it. And you do not become better at math by watching other people do it. So you can watch me do these and say, oh yeah, that looks pretty easy. I think we got this. But until you actually try it yourself, you're not going to know. So make sure you're taking notes on this stuff, either on your review sheet or if you want to do your review sheet later on a separate piece of paper. Okay? And be working through this stuff because this is exactly what you're going to see in the quiz tomorrow. There's absolutely no excuse for someone to bomb one of these quizzes. I tell you exactly what's going to be on the quiz. The only thing that's going to change are the numbers. All right? So you have no excuse for doing poorly on this quiz other than the fact that you aren't spending any effort actually preparing yourself. Because we're showing you exactly how to do it, and then we show you exactly what's going to be on the quiz, and we spend a week going over it. So step up a little bit, folks. Some of you really need to pick up the game. All right. So Pythagorean theorem to start with. Find the missing side of each triangle, leave the answers in the simplest radical form. Clearly, when I know two sides of a right triangle, I need to find the third side. The obvious method that we are going to use is Pythagorean theorem. And again, this is not new to geometry to you this year. This is review. And remember with Pythagorean theorem is just a squared plus b squared equals c squared. But just like in the other time where the x is not the one that's always by itself, here the unknown could be at any one of these positions, either a, b, or c. And we got to figure out where it is. Now, A or B are kind of interchangeable, but C has to be the hypotenuse. Okay, the other two represent the legs of the right triangle. So here, where's the hypotenuse of this right triangle? You usually want to find that first. In fact, I often will circle it. There's my hypotenuse, so I know that's one that goes by itself. So it's going to be x squared plus 11 squared equals 12 squared. And I usually try, just my own mind, to go smallest to largest. But if I switch these two, it's not going to make a difference. And it's got to be the squared, so that's x squared plus 121 equals 144. Subtract the 121. So x squared equals, what is it, 23. So x equals the square root of 23, which does not simplify. 23 is a prime number. We can't reduce that. Here, the hypotenuse is this one, so that's one that's going to go by itself. The x is one by itself this time. So square root of 7 squared plus square root of 13 squared equals x squared. And again, as you're doing this on the test, make sure you write out this part carefully. Don't be lazy and skip that step. Because if you do make an arithmetic error here, an algebra error here, at least they know you set it up correctly, and that's worth points. Okay? Square root of 7 squared, square root and squared are opposite functions. They cancel, actually inverse functions is the correct term. They cancel each other out, so that's 7 plus 13 equals x squared, so 20 equals x squared, so x equals the square root of 20. But it does say simplest radical form. So I got to reduce that radical. That doesn't mean decimalize it. That means square root of 4, square root of 5, 2 root 5. And for the final time, hopefully I will have to remind you that if you do not know how to do that reducing, watch those extra help review podcasts that I've created that address that topic. Okay, check the hit counts on those the other day. They like 2 or 3 views, which means either you guys are like experts at reducing radicals or just don't care enough to look it up. One of the two. I don't know. Hopefully it's the first. It should be an x here, sorry. And again, that is the hypotenuse. So it's square root of 26 squared plus 11 squared equals x squared. So it's 26 plus 121 equals x squared. So 147 is x squared. So x is the square root of 147. Now, what goes into 147? Any perfect squares going into 147 that I can think of. Let's go through our reducing process on this one. 147 is obviously not a perfect square. So I start with perfect squares less than half, 1/2 of 147 or less. So 147 divided by 2 is 73.5. So 64 will be the first one I'm checking. Does 64 go in? No. Now, does 49 go into 147? 147 divided by 49. It does, 3 times. There it is. Simplifying radicals is one of those really important skills you are going to need in Algebra 2 and beyond. All right? Make sure you are aware of how to do that. Find the area of the isosceles triangle. Some people got a little stumped on these. It's a little different. But again, if it's an isosceles triangle, how do we find area of a triangle? Area is base times height divided by 2. And the height is the altitude of the triangle. Now, I don't know the heights of these triangles. But because they're isosceles, I can find them pretty easy. Okay? So I've got my base, and I've got my height, and I'm just going to have to divide those 2 by 2. But I'm going to have to figure out what that height is, aren't I? Now, here, because we're looking for area, and we're probably going to decimalize our square roots. On area problems, they usually just decimalize and approximate. So I do have to set this up. Set up this. Now, the whole side is 14.4, so that's going to be 7.2. And that's the hypotenuse, so it's 7.2 squared plus x squared equals 8 squared. Now, 7.2 squared, I better get a calculator out for that, because that one I don't know off the top of my head. 7.2 squared, 51.84. Don't just round that to 52. Use all the decimals that are there. Plus x squared equals 64. So 64 minus that is 12.16 is x squared, and then we take the square root of that answer. And it's about, for 2 decimals, it's 3.49. Okay? Go ahead and use a couple decimal places of accuracy. The number's pretty small. Okay? So now the area, now that I have this, 3.49, the area is simple. The area equals the base, 14.4, times the height, 3.49, divided by 2. So 14.4 times 3.49 divided by 2. And 25.128, 25.13, we'll say, meters squared. There's my area. So it's Pythagorean theorem plus. A problem like that is Pythagorean theorem plus. So applying Pythagorean theorem. Same thing here. What's my base going to, when I break this triangle, how long is this side going to be? 6. So my right triangle, there's my hypotenuse. 6 squared plus x squared equals 11 squared. 36 plus x squared equals 121. X squared, that's 115 equals 85. So x is the square root of 85, which is a little more than 9. How do I know that? It's a little more than 9. Square root of 81 is 9, right? And 84 is a little bigger, so 85 is a little bigger. I get 9.22. Now we have to find the area, finish the problem. Area is base times height divided by 2. or 55.32. Meters squared. Okay, remember area is always measured in units squared. That's nothing new to us. So those are a little bit more work with Pythagorean theorem plus. Area of a triangle formula is one that should be very familiar to you probably since about 3rd grade. But it's an application of that. Acute, right, or obtuse. Do not just answer acute, right, or obtuse because that will, even if it's correct, it's only going to get you 1 out of 3 points. Okay? So we're going to need to do something more. We're going to need to show our work. And the way that we show our work is by setting up a Pythagorean theorem, but instead of with an equal sign, we use the blank. A lot of us talked about this while you were actually working on the homework. I went over this with a lot of you individually, where people want to put the equal sign, don't put the equal sign in right away. Leave it kind of blank. I also have to figure out what is the longest side, because it may not be obvious which side is the longest side. So sometimes if I get something like a 3 root 34, I may actually have to take my calculator out and go 3 times the square root of 34. That's about 17.5, so that is indeed the longest side. Get a quick decimal approximation so I know which one is longest. This is the longest side, so that's the one that's going to be by itself. Okay? So I check 9 squared plus 15 squared compared to 3 root 34 squared. Now 9 squared is easy, 81. 15 squared is 225. So together that's 306. I'm going to compare that to 3 root 34 squared. Now, use your calculator. Okay? Take that decimal value you got for 3 root 34 and just hit your x squared button. Equals. And it's 306. Okay? Be a little careful. You can't just put in 3. If you just type in 3 square root 3, 4, and then your x squared button, you're only going to be squaring the square root of 34. You're not going to be squaring the 3. So be careful about that, how you enter it in your calculator. You want to hit 3 root 34 equals, and then square that answer. So get the value of 3 root 34 first, and then square it. Or if you want to do it manually, 3 root 34 squared is 9 times 34, because I square both the 3 and the root 34. 9 times 34 is 306. They are equal, so what kind of triangle is that? Right. Just 5 root 7, I'm not 100% sure of that value, so I'm going to approximate it. 5 times the square root of 7. It's about 13.2. Okay, that is not the longest side. 16 is the longest side. So 10 squared plus 5 root 7 squared compared to 16 squared. That's 100. 16 squared is 256.
Pardon the interruption. The first wave of students to reality
That's great.
can be dismissed now. That
And 5 root 7, and we square that, is 175. So that's 275, 256. Oh, 256 is too small, which means that triangle is acute. Is the hypotenuse too big, too small, or just right? That's what the question is. Is the long side too big or too small, or just right? Small is acute. Big is obtuse. Right is equal. Again, a couple more. A root 13, 2 root 2, and 2 root 3. Again, I'm going to approximate them just to make sure. Square root of 13 is about just a little less than 4. Root 3 is 1.7. 2 root 2 is about 2.8. So, yeah, that's the longest side. So, 2 root 2 squared plus root 3 squared compared to root 13 squared. 2 root 2 squared is 8. Root 3 squared is 3 compared to 13. 11 compared to 13. Oh, 13 is too big. Therefore, this is obtuse. Okay. Once again, checking. I checked 4 root 10. It's about 12.6. So this is my longest side. So 5 squared plus 12, sorry, just 12 squared, compare to 4 root 10 squared. 25 plus 144, that's 169. And 4 root 10 squared is 16 times 10, or 160. Oh, it's too small. This is acute. So half the work here is knowing the Pythagorean theorem and how to use the converse. The other half is just knowing how to work with the radicals. And always be checking to make sure that what appears to be the longest side actually is. I have a feeling that there's maybe one on the quiz where it may not be exactly as it appears, and you have to switch sides a little bit to make sure that you're always hitting the longest side by itself. Okay? All right. Next is our 45, 45, 90 fun time. Now, you do have to have, obviously, these two pattern triangles memorized. Actually, there's 3 of them, 2 for the 45, 45, 90, depending on where things are at, and 1 for the 30, 60, 90. You can get away with just 2 if you need to, okay? But our 45, 45, 90 pattern triangle is this. The legs are the same. The hypotenuse is a leg times the square root of 2. So, if I give you one leg, the other leg should be like a freebie, right? Whatever one leg is in a 45, 90, the other one has to be the same. It's isosceles. 2 angles are the same. 2 sides have to be the same. So clearly, without even having to know the pattern, this is going to be 6. And this v here has to be 3 root 2 over 2. And this n has to be 9 root 2 over 2. Marvelous, okay? So there's no work required for those at all. M should be pretty obvious. 6, 6, what's M going to be? N root 2, 6, 6, 6 root 2. This one actually isn't bad. It's 4 root 2 for the hypotenuse, so n must be 4. I mean, even if I just get those 2, I've already got like 1, 2, 3, 4, 5, 6 out of 8 points on that section, don't I? Just that quickly. Now, the other 2 are a little trickier, so what am I going to have to do? I'm going to have to take whatever the leg is times, for this pattern, the square root of 2. So 3 root 2 over 2 times the square root of 2. And I got to simplify that. So here's where the algebra gets tricky. Not horrible, but root 2 times root 2 is 2. And 3 times, so it's 3 times 2 over 2. The 2's cancel, or you could multiply, get 6 over 2. Either way, it reduces to, this is 3. And this one, this is 9 root 2 over 2 times the square root of 2, which is 9 times 2 over 2. The 2's cancel, and this is 9. Okay, so that's that pattern. Then we switch patterns to the 30, 60, 90 triangle. Do not mix up the patterns. Using the wrong pattern is bad. Okay, the 30, 60, 90 pattern is we have our short leg is our base measurement, and then the hypotenuse is twice as long. The long leg is n times the square root of 3. I'm pretty sure I'm not putting too much on here that's going to be super nasty type things. Oh, I forgot a square root symbol here. Sorry. Computer doesn't type in square root symbols really quickly and easily, so you can tell I handwrite them. So let's start with this first one. I know it's a 30, 60, 90. Should have right angles in here too. The short leg is 4, so how long does the hypotenuse have to be? 8. Just double it. And so y has to be the short side times the square root of 3. Okay? Oh, here they give me the long leg is 3 root 3. So what does the short side have to be? Work it backwards. N root 3 equals 3 root 3, so n must be 3. So this has to be double which? Am I doubling the long leg or the short leg for the hypotenuse? Short leg, so double 3 is 6. And same here, b is going to be 9, and this is going to have to be 18. The only one that's tricky here is this where I give you 7 root 6 over 2. Ooh. That's kind of a messy one. I give you the hypotenuse. This has to be half of that, doesn't it? Or 1/2 times 7 root 6 over 2. And the 2 times 2 gives me 7 root 6 over 4. So that one's kind of ugly. But, you know, there's always that one that kind of tests your algebra skills a little bit. And this has to be this number times the square root of 3, doesn't it? So 7 root 6 over 4 times the square root of 3. I can only combine the square roots, so that's 7 root 18. I'm going to do it down here. Over 4. But I can simplify square root of 18. That's 7 root 9 root 2 over 4. Root 9 is 3. 7 times 3 is 21 root 2 over 4. And that's that length. So that's a pretty ugly one. There's always going to be that one problem that really tests your skill with the radicals and your ability to simplify. Most of the work here is going to be much more like the simpler ones. But just be prepared to do some algebra work with those radicals. Find the geometric mean between two numbers. How do we do it? This should be a freebie problem for everybody. Find the geometric mean between two numbers. How do you find geometric mean? Multiply the two numbers and take the square root. What's 9 times 4? And simplify it, which is awesome here because that's a whole number. Okay? Some people just see that word mean and they add and divide by 2, and we know that's not the case. That's an arithmetic mean or a statistical mean. This is a geometric mean. It's a completely different type of measurement. Okay? So when you see this problem on the test, that should be a quick freebie points for you because it's a pretty easy process. Multiply the numbers, take the square root. Finally, find the length, leave the answer in simplest radical form. Now you'll notice that this is what, like one problem on the review sheet here? I'm sorry. Maybe I didn't get all these on the, maybe I didn't get my review finished with this. That's okay, we'll write the other one then. Okay. It's 4 problems on the review sheet. The review sheet's usually about twice as long as the quiz. So just kind of remember that. Not as many problems on the quiz. We can set this up with triangles. We can set this up with geometric means. It's up to you. Let's set this one up with triangles. If you were going to set this up with geometric means, just a quick hint, all 3 segments have to have the same endpoint. 64 here only goes this far. So I'd have to actually add these to get that the whole thing is 100, and it'd be x equals the square root of 36 times 100, which is 60. Okay, so if you're doing the geometric means method, that's how quick it is. That's the nice thing about that. It's really fast. If you're doing the triangle method, we draw Papa, Mama, and early adolescent triangle. Papa triangle has a hypotenuse of 100 and a short leg of x. Mama triangle has a long leg of 64. We don't know short leg or the hypotenuse. Baby triangle has a short leg of 36 and a hypotenuse of x. And I get x over 36 equals 100 over x. So 3600 equals x squared. So x equals 60. More work, same answer. Either way. Okay, let's look at the next one. Sorry, I didn't need these drawn out, but I can draw these out quick. I thought I finished this. Oops, wrong line. Okay. So our measurements are x, 25, and the whole thing is 169. This is one that is definitely set up for geometric mean calculation because x is the square root of 25 times 169. Okay. So, and this is super simple because square root of 25 is perfect square. That's 5 times 13 because both of these simplify out as perfect squares. 5 times 13 is 65. Or you could multiply them and put them in your square root. You get the same thing really fast. Okay? Or we could set up our 3 triangles and do the same thing. This next one I'll do with triangles just for fun. X, 25, and 144. So our triangle looks like this. So we have X, 25, and 144. Again, right angles here and here. So let's do our 3 triangles this method. Big outer triangle, I have a hypotenuse of 169. Long leg and short leg, I don't know. Middle triangle, I have a short leg of x, a long leg of 144. Hypotenuse, I don't know. Little triangle, I have a short leg of 25, long leg of x, hypotenuse we don't know about. And again, pretty obvious how it sets up, 144 over x equals x over 25. So x squared equals whatever 144 times 25 is. 3960? 3600? Okay. So x equals 60, taking the square root of both sides to solve it. Okay. '22. We've got a 64, an x, and the whole thing is 100. Now this one, if you're doing the geometric means, you have to be careful with, because again, all 3 segments we're working with have to share an endpoint right here. And the 100, the endpoints are on either end, so I'd have to actually get this 36 right here. So if we're setting this up, geometric mean, it's x equals the square root of 64 times 36, which is 8 times 6, or 48. If you're setting it up with the triangles, you're less likely to make a mistake on that one. So if you're using the geometric mean method, be careful. Be very careful with that one. I do have to do a little bit of addition, subtraction there before I can set up my equation. Although once we've done that, it's pretty fast. And that's it. Okay? So there's your review. Again, use what we've done today now, study it over the weekend, watch this podcast again. I'll get this published, or check out these notes. I will have all the notes with all the workout solutions online on the Schoology page probably within the next hour. So make sure you're taking care of that. Don't just walk away from today's lesson going, I got this, and come in on Monday cold, because you will not be happy with your results probably. Okay? Spend some time this weekend studying. I don't mean you have to spend the whole weekend doing it. I mean spend 15 minutes here, 10 minutes there, 5 minutes here. Go over one section. Make sure you know those pattern triangles. Okay? Make sure you know your 30, 60, 90, and 45, 45, 90, and have them differentiated. That's pretty critical. By the way, those triangles, huge in pre-calc and trig. So if you're planning on going on in math beyond Algebra 2 ever, the 30, 60, 90, and 45, 45, 90 triangles are massively important. In fact, most of the first semester rests on those two triangles in pre-calculus. They're the basis of everything we do almost. So if you plan on going on in math and studying any higher math, especially trigonometry, you really, really, really want to memorize those triangles. They come back in a big, big way. All right.